There is then some stuff that we need to add. We have forgot the bypass here. That needs to be added. So we do that then. We had used 14 already, 15 maybe, that was available, 16 then, like that. Now this is on the utility, it's cooling water return. We most likely will not put a drain here because it's only water. Otherwise we should do that. And here we should be able to control the flow in case of maintenance work. So we put a globe here. So now it also become apparent that we need, as we have done for all the others here, we have put open action, and this is normally open. Here we are normally open also. But here we are definitely not normally open, we are normally closed. Like that. So this is good enough, I think, for the bypass. We then need to add some more stuff to the equipment, and that is data boxes. And they are typically located in the different labels folders. Tank description here, for instance. So we use this, we try to attach it, we see we got it attached here, we click and then we're going to place it. It should be placed down. We zoom out to see where. Oh, then we lost it, but we can grab it again. We grab this and place it. It should be placed down here, like that. Pumps should have labels like that also. Centrifugal pump. not compressor, centrifugal pump, like that, and we can place this here. And we had heaters, exchangers. Like this. So we look here. What do we have? We have nice boxes, but there is no information at all inside here, and it is typically a little bit tiresome to find. We have to fill in the form, fill in this information, but the trick is to select it like this, and then we see all the fields that should be filled out. Absorb duty. Here we can, you could use some other unit like that if you prefer that. The thing that comes up is the one we actually would like to have. So we put 1000 kilowatts there. Okay. Heat transfer area is 200 square meters, we say. It's 316L. And that come up. Here's the tube, and here's the overall, and we have 316L. You see, you get the tooltip here also. If you hover slowly over it, design max pressure, then we are on the shell side, and the tube side is something different here. Bar gauge. Okay. $150 design tube max. Oh, we have the same, we say, in this case. Operating pressure is normally not more than 6 bar, and the temperature should not be more than 50, we say. And well, that was on the shell, because it's the cooling water that is typically what we have. Tube, we have a lot more, we say. Lot, we have 8. And the temperature will that be maybe 60, like that. The thing is, I have to highlight this for you, that this is no information. That is only some of the information to fill out here. But that is at least the minimum that should be shown on the SPPID that we need to fill out. And There might be some more that we need to fill out. Rated duty. Is it sloped? We need to put that. Tube lengths. Maybe. There might be alternative. We have different mode we operate in. We could put more. Something that we typically should put is test pressure also. So this is the way you fill out the information for the other equipment in exactly the same way. Casing material, diameter of impeller we would like to have here, and PSH available like this, and that can be found then here for all the equipment. And every itemized equipment should have a data box like this. What we then has forgotten to do is to add motors, electrical motors. You have a pump here that needs an electrical motor. Out of the box, Intergraph provides you with one symbol for our electrical motors. We have divided them for one for each type we have. We should use the ppm type. This is also something that if you hover over something you can get relation when it comes to aligning. If you want to put in angle here, it shows where it is in an angle. We typically put center line here and go out a little bit and then place. I release this. Then we get some points to drag here, and we zoom close first so we can see what we're doing like this, and we try to get hold of one of these. It wasn't easy at all, I realize. Now I finally got hold of it. Drag it to undo. You try to get hold of this. It is not happy with me at all. We can now. I make it easy for me. I just move it with the moving tool. I move it 3. I thought I should move it. We'll try again. Alright. It's not easy at all to move anything here. This is typically what happens. You get out of grid. I just try to grab it someplace. Try to grab it here instead. It doesn't work at all. And you see it also becomes out of grid. As you can see, we can make it with this. It's a hassle. No, he simply doesn't want. Okay, we redo the placement simply. Delete to stockpile. Drawing. What do we have in the stockpile? We have a driver. Okay, we take that one, we place it again. Okay, good. You take hold of one of these if that is possible. Maybe not so easy. You have to release it and try it again. Try over there. Then it's become too much. You go back maybe. Alright. Second time. He's not happy with that at all. But he becomes happy when we come there. It's a hassle. That could be looked over by Mr. Bayek. We need then to be able to start and stop the motor. Okay, then we need some instrument. Or actually we need a connection to the DCS. What connection then? Yes, we need a Handswitch. So we have a measured variable that is then H, and we have a modifier S, like this, and we have an operator line to this then. And it gives us a inconsistency. It's not attached. Okay, why is that? Because this is an equipment type electrical motor, and to connect there we need what? We need nozzles. So we put an instrument connector here like that. It gets 01 as a number. Okay, and then we can attach the line there. Ah, beautiful. Now there is one thing that we need to consider, and hovering here we say that the instrument can have soft it can have signal points and signal levels attached. So we are going to use that to show what you can do from the DCS with this Handswitch. We click here. Signal point 1 to 4 is shown here. So we use the above one to put not an alarm or anything. In this case we put running open close failure. There could be running close failure, running and failure, or only open and close. And we have running open close failure. So that we put in signal point 1 to show that we are able to open and close from the DCS, and it will show failure and running also in the DCS like this. Then we also need to give this motor a tag, and the tag number should be, in this case, the number should be same as on the motor, 02 then, like this. So ppm 002 will be this. The tag number for this electrical motor. Just to show you again what we have. So overall, it looks like this. Just to tease you about the engineering data editor I have put here. It's a filter that searches everything that we have now in the drawing stockpile and in the drawing when it comes to equipment. And you see here we have 4 equipment: a tank, a pump, exchanger, and a driver. What I would like to show you now also is how to place and how to show process OPCs. So we zoom in. We need to feed the tank in some way also. Okay. We then have something, main flow coming here, touch here, we hover over this line here, we get the stripe here, so we know, then click, and then we're going coming from here somewhere. Okay, click and release. We would like to have an OPC, a process OPC here, and we go off drawing like that, and we should have it in the end here. So what we see is that we need to shorten the line a little bit before we place this. We leave it back there somewhere, and it will enter, so we are coming there, and we place it to the main grid line when there is where it should start. And we use the same drawing as before, even if this is faulty, as you know. We check this a little bit closer there. What does it, yeah, come out a little bit more. So we say this is the first main grid line where we should end with this, and we attach the OPC here. That, and it hopefully can connect, but cannot evaluate. That is good. Same as with the utility OPC, we get a small number there. Okay, that is good. Now we have a to and from and a description. And here we should say from which branch or piping or from what equipment this line comes from. We just invent something here, a pump. Like that. Okay. Then in the description field should say, in general, it should say what we have in the as a fluid in this system. As in refineries, you know, you use the fluid code P for everything. That is not utility, so you have no idea actually what is in the line. We can invent something here. Then we say it's crude oil, like that. Okay. This is how you place and show the OPC. It comes from a file called test. So we had the 2-inch line. We should then always, when it has an upside, there should be a label immediately close to the upside. Like this. So most likely we have a B, 150B again, as we had before. Of some reason the nominal line size is not given. It should be given by the nozzle. Maybe this is the problem here. We should see the connection point is not attached. Okay. So you see how useful this is with a we are still not in touch at all of this, and it might be because we're hovering over this one. We'll say we move that away. Typically you see now we got one there and it fixes this. Typically tip, when you have a problem, you move it back. So it loves the 2-inch. Fluid code is still P. Like that. Size we have given. What can be left? Not much more than line number. And here we go with number 5. Like that. And the crude oil in Nynäs would be heat traced and insulated, but we'll leave it as it is.